Hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. Hello. I'm excited to discuss your study on the impact of quantum computing on cloud computing. Could you please provide some background on the purpose of your study and what motivated you to conduct this research?
Certainly. The purpose of our study was to analyze the impact of quantum computing on cloud computing. As quantum computing is becoming more popular, it's important to understand how quantum machines can be accessed and used efficiently through the cloud. We were motivated to conduct this research because there is a growing demand for quantum computing resources, both from academic researchers and industry professionals. However, there is a lack of analysis and understanding when it comes to managing quantum computing jobs and resources in the cloud. We wanted to fill this gap and provide valuable insights for efficient job and resource management in the quantum cloud.
That's really interesting. It seems like there is a need for a better understanding of how quantum computing jobs and resources are managed in the cloud. Could you tell me more about the specific focus of your study? What aspects did you analyze in order to gain insights into the trends and characteristics of quantum computing on the cloud?
In our study, we analyzed various aspects to gain insights into the trends and characteristics of quantum computing on the cloud. Some of the aspects we focused on include 1. Execution times on quantum machines. We looked at how long it takes for a quantum machine to execute a quantum circuit. This helps us understand the efficiency and performance of different quantum machines. 2. Queuing waiting times in the cloud. We analyze the amount of time a job has to wait in a queue before it can be executed on a quantum machine. This helps us understand the demand for quantum resources and the efficiency of job scheduling. 3. Circuit compilation time. Quantum circuits need to be compiled before they can be executed on a quantum machine. We examined how long it takes to compile different circuits, which is important for optimizing the overall execution time of a job. 4. Machine utilization. We studied how effectively quantum machines are being utilized in the cloud. This includes analyzing the percentage of time a machine is being used for executing jobs versus being idle. 5. Impact of job and machine characteristics. We also looked at how different characteristics of jobs and machines affect the trends and characteristics mentioned above. This includes factors such as the size and complexity of the quantum circuit, the number of shots or trials, and the specific features of the quantum hardware. By analyzing these aspects, we were able to gain insights into the performance, efficiency, and resource utilization of quantum computing on the cloud.
Thank you for providing such a comprehensive overview of the aspects you analyzed in your study. It's fascinating to see how you examined execution times, queuing waiting times, circuit compilation times, machine utilization, and the impact of job and machine characteristics. Based on your analysis, were there any notable similarities or differences between quantum cloud systems and classical high-performance computing, HPC, cloud systems? Can you share some insights into how quantum computing behaves differently in terms of resource consumption and management compared to traditional computing systems?
According to our analysis, we have identified several similarities and differences in resource consumption and management between quantum computing and classical high-performance computing, HPC, cloud systems. In terms of resource consumption, both quantum and classical computing systems require resources to execute jobs. However, the nature of these resources and their utilization patterns differ. In classical computing, resources are typically measured in terms of CPU cores, memory, and storage, while in quantum computing, resources are measured in terms of the number of qubits and the number of quantum circuit executions. Shots. One key difference is the impact of job and machine characteristics on resource consumption. In classical HPC systems, job characteristics such as task size and runtime can impact resource consumption. However, in quantum computing, Job characteristics such as the number of qubits and the complexity of quantum circuits can greatly impact the resource consumption. Additionally, machine characteristics such as the fidelity of the qubits and the efficiency of circuit compilation can also affect resource consumption in quantum systems. Another difference lies in the queuing and waiting times in the cloud. In classical HPC systems, queuing and waiting times can be influenced by factors such as the number of job requests and the availability of resources. In quantum computing, queuing and waiting times can be affected by the limited availability of quantum machines and the high demand for quantum resources. This scarcity of quantum resources poses challenges for efficient resource allocation and job scheduling in quantum cloud systems. Furthermore, the analysis of resource consumption and management is more mature in classical HPC systems compared to quantum computing. In classical HPC, there are established techniques and algorithms for managing resource allocation, optimizing job deployment, and predicting execution times. However, in quantum computing, these techniques are still in their nascent stages of development, and further studies are needed to improve resource management strategy. In conclusion, while there are similarities in terms of resource consumption and management between quantum and classical computing systems, there are also notable differences. The impact of job and machine characteristics, the scarcity of quantum resources, and the need for further research in resource management are some of the key distinctions between quantum and classical HPC cloud systems.
Thank you for providing such insightful insights into the similarities and differences between quantum computing and classical high-performance computing, HPC, cloud systems in terms of resource consumption and management. It's interesting to see how the nature of resources, the impact of job and machine characteristics, and the challenges of resource allocation differ between these two domains. Based on your analysis, what are some of the key recommendations and contributions that you have made to improve the management of resources and jobs on future quantum cloud systems? Could you highlight a few important takeaways from your study?
In our study, we have made several key recommendations and contributions to improve the management of resources and jobs on future quantum cloud systems. Here are a few important takeaways from our study. 1. Resource consumption analysis. We recommend conducting a detailed analysis of resource consumption in quantum cloud systems. This analysis should include factors such as the number of quantum machines available, the number of users and jobs submitted, and the queuing and execution times of jobs. By understanding the resource consumption patterns, providers can effectively manage their resources and ensure efficient utilization. 2. Job characteristics analysis. It is crucial to analyze the characteristics of jobs submitted to quantum cloud systems. This includes understanding the size and complexity of the jobs, the estimated execution time, and the priority or urgency of the job. By analyzing these characteristics, providers can prioritize jobs, allocate resources accordingly, and optimize job scheduling. 3. Collaboration with quantum hardware vendors. We recommend establishing collaborations with quantum hardware vendors to improve resource management. By working closely with vendors, providers can gain insights into the capabilities and limitations of different quantum machines, and accordingly, optimize job allocation and scheduling. 4. Development of scheduling algorithms. We propose the development of efficient scheduling algorithms specifically designed for quantum cloud systems. These algorithms should consider factors such as job characteristics, resource availability, and system load to make intelligent decisions about job allocation and scheduling. This can lead to improved job turnaround times and resource utilization. 5. Continuous monitoring and feedback. Providers should implement continuous monitoring mechanisms to collect real-time data on resource consumption, job characteristics, and system performance. This data can provide valuable insights for making informed decisions about resource management and can also be used to refine scheduling algorithms over time. By implementing these recommendations, Future quantum cloud systems can effectively manage resources and jobs, optimize job scheduling, and ensure efficient utilization of quantum machines. This will result in improved user experience and maximize the benefits of quantum computing in the cloud.
Thank you for summarizing the key recommendations and contributions from your study. It's evident that conducting detailed resource consumption analysis, analyzing job characteristics, collaborating with quantum hardware vendors, developing scheduling algorithms, and implementing continuous monitoring mechanisms are crucial for improving the management of resources and jobs on future quantum cloud systems. These recommendations provide valuable insights for providers and researchers in the field, enabling them to optimize resource allocation, job scheduling, and overall system performance, thereby enhancing the efficiency and effectiveness of quantum computing in the cloud. Is there anything else you would like to highlight, or any additional insights you would like to share based on your study?